Hello and welcome. If you've stumbled upon this video, then you, like me, are about to embark on a very fun quest of using Python as part of your repertoire, as part of your research tool bag in your pursuit of the digital humanities, or if you're like me, digital history. So, why did I decide to make this video or these series of videos? The reason why I decided to make these videos is because, as far as I can tell, there isn't anything available that's specifically designed to introduce humanists, non programming humanists, to Python, to a programming language that is specifically geared for data analysis. And so I'm trying to fix this problem by making a series of videos doing just that. I came up with the idea because at MIT, as I understand it, math majors have two courses that they can take. And these are ways to introduce non-programming math majors to Python, because Python is essential for their pursuit of research and math. Because Python is very good at using different modules or libraries, I'll get to that later in the video, to handle advanced mathematics. However, naturally, the way in which these courses are structured is specifically for math majors. So the problems addressed, the code that's being written is all geared towards the kinds of problems that math majors will encounter. This might not come as a surprise to you, I hope it doesn't, but the problems we humanists face are fundamentally different than the problems math majors face. So, what do we do? Well, the solution's obvious. Make a series of videos that introduce humanists to Python so that you all, like me, can start using it as part of your really research methods. And so that's what these videos are going to do. And I'm going to do this in a very structured way, like a typical 30 lecture course. These are going to be short lectures, though. I'm not going to put 50-minute lectures up. They'll be as long as they take. What I'm going to do is essentially introduce you to the key concepts of Python while showing you along the way how these key concepts fit into the needs and the uses of the digital humanist. So the first thing that we're going to look at in this course after this introduction here is we're going to look at the ways in which you can store data. And this is done in a bunch of different ways in Python, but early on in these lectures, I'm going to just give you the basic ones so that we can have a framework for doing more advanced stuff. And I'm going to go through and talk about each one of these in depth in a series of, 3 to 7, lectures 3 to 7. And then we're going to talk about how to start using this data in more complex ways through branching conditionals, such as if-then statements. In Python, they're formed by saying if, elif, and else. Again, I'm going to talk all about this in each individual video. This is just to give you an idea about what we're going to be going over in this series alone. Then we're going to start talking about loops. We're going to start talking about the more complex but fundamentally necessary parts of Python, and that's functions and classes. A lot of times we humanists work with texts, naturally. So I'm going to show you how to actually interact with text files. This is something I use every single day. And then we're going to switch tacks and we're going to start introducing you to the particularly useful libraries or modules in Python. Now, a Python module or library, you see here under new concepts, number 5, is a third-party library that's been written. And what it is it's a series of code that can be called and manipulated by inserting attributes that return values. I'm going to explain all about that in later videos. But when you look at the MIT lectures, they're geared towards math. So the modules that they talk about and the modules that they use are always math-centric modules and libraries. Modules or libraries are kind of interchangeable terms. What I'm going to do is I'm going to show you the libraries that I use on a either daily or near daily basis. And that's what the second half of this course is kind of geared towards, is how to use them, some of the most important functions of these libraries, the ones you're going to use every single day, and kind of really just get you fully immersed into Python. And as we go through in each of these lectures, I'm going to be showing you creating code on the fly, to demonstrate stuff, but I'm also going to be bringing in some of the code I've written for my own personal research to demonstrate the utility and power of Python and of these libraries. And then we're going to wrap up this course with basically how to create a simple GUI, or a graphic user interface. This is a way in which you can interact with the program without actually having to interact with the code. It'll have buttons that you can press to do very specific tasks. I'll talk all about that in lecture 30. This is some of the things that we're going to be covering, though. But first, let's ask a very simple question. What is Python? Python is a programming language. It was invented in the 1990s as a way to do one very, very important task, and that was to write code quickly and neatly. And it does this through indentation or white space. So in Python, when you write code, it's going to, here, pull up one right now. We're going to use this a little bit later. You're going to notice that there are indentations for each set of code. So each indentation delineates a certain aspect and layers your code so that it's not all over here on one side, one margin. This allows for you to easily read code and parse it out, even if you didn't write it yourself. So that's what indentation in white space is, and that's why Python is extremely preferred by data analysts and people who do neural networks, everyone, because it's very easy to write, it's very clean-looking code. It's not exactly the most efficient when it's performing a task. C++ as a programming language is better at that, but the time that you save in writing the code is very good, and people prefer it for that main reason. It's also a very useful programming language because the Python community, is incredibly vast. And that benefits Python in two ways. The first major way it benefits Python is that it has created a community that provides free open source content in the form of these modules or libraries, which can be used by people like me who are not programmers first, but rather use programming to perform other tasks. So that I don't have to spend weeks or months writing code. I can simply spend a few minutes getting used to the module or the library, learning its functions, and then using those functions all within probably an hour. That's fantastic. The other way that Python, the vast Python community has benefited Python as a programming language is that any problem you will have, the solution can be found on the internet. I have personally found stackexchange.com to be one of the best places that you'll find answers. But honestly, if you get stuck, just type a question into Google, and it'll take you a few pages here or there on the Google results, but you will find the solution. I have yet to encounter a problem in Python that I have not found the solution for by simply asking Google the question. Google's fantastic in that sense. And so that's kind of why I use Python, and that's why a lot of people who perform data analysis use it as well. So the first thing you probably need to know is how to actually install Python. And the way in which you're going to do this is simply go to Google and type in Python download. It's that simple. You're going to go to python.org, and I'm going to be working with Python 3.7 in this video. So you're simply going to go here, download, and install Python. I'm not going to go through all of this, but this is very important. In the installation process, you're going to get to a point where it asks you to expand the character limit of 256 in Windows. You're going to want to do this. What this is going to allow you to do is to install modules and libraries in Python's directory without the risk of Windows not reading a folder because the 256 limit has been met. I don't really want to go into that. It's important. You have to do it. The other thing you're going to want to do is it's going to ask you to install a path. You want to install the path for Python. I'm going to be talking about why in just a little bit. But you want to install the path essentially because it's going to allow you to install um, Python libraries in that path. And again, I'm going to get to that when I talk about pip install. The next thing that you're going to want to do once you download that, I'm just exceptionally lazy and I just download things this way, is you're going to want to install Atom. And what Atom is going to do is it's going to allow you to write your code. Now, Python comes with a standard IDLE. It looks something like, I'll pull it up right now in just a second. Or maybe not. There we are. It looks something like this, which allows you to write code on the fly and have it output. This is the shell. It also has a standalone IDE where you can open up and create Python scripts. This, however, looks very clunky. Most people don't like to use it. Instead, they opt for these third-party IDEs that allow them to actually run their code. I prefer Atom over Sublime Text, which is kind of the way most of the community is heading, it seems, right now, for a bunch of different reasons, but it doesn't matter what you use as long as you use something to write your code in. Atom's nice because, like Sublime Text, you can actually structure your program directory. You can call past files. You can do a whole bunch of different stuff. And on top of that, it's nice and color coordinated. It's easy to read. As you can see, purple with a with expression. Open is in this teal. Strings are rendered in this green, etc. It's nice. It looks pretty. I like it. I also like how it's displayed. You'll see in a little bit when I run this code, the output's displayed on the bottom. But I can have 3 windows open if I want to. I have a 4K monitor, so I got a lot of space. But overall, Atom is just a very useful way of running your program. So you're going to want to download this and install it. But unfortunately, Atom will not run on its own without doing a couple different things. So what you're going to need to do is come over here in Atom once you install it and configure it. Nope, wrong button. You're going to install these packages. I'm going to show you how to do that in just a second. Settings. There we go. And what you're going to want to do is come over here to install. And what you're going to install, let me just show you what I've got installed so you can see. Okay, you're going to want to install all of these right here. So take a moment, pause the video, and write down all of these names exactly as you see them. These are all going to be very important because these are going to allow you to write code in Atom and have Atom read Python and run Python. Okay, so the way in which you're going to install these is you're going to come over here and you're simply going to type them in. And you're going to see that I already have it installed, but if I didn't, I would click this button right here, install. And for each of those packages, you're going to install them. This is going to allow you to run Python, and in later videos when we start working with XML, it's going to allow us to actually start working with XML files as well. So once you do that, go ahead and replay this video. I'm going to go ahead and keep on speaking. So once you have all of that, you will essentially have all the stuff that you need to run Python for this whole video series. But there is one other thing that you're going to encounter that you should really be familiar with, and that's a program built into Python called pip. And pip allows you to install different libraries or modules. And it's quite simple to use. All you're going to do is simply open up your command prompt, and you're going to type in pip install, and if you're going to be using this later on in the lecture series, and I'll tell you what to install. But XLRD is one that we're going to be using, which allows us to actually process and handle Excel files, or at least read them. And if you notice, it's taking time to install, but I already have it installed, so it'll tell me that. See, requirement already satisfied. For you, however, if you don't have this installed, it will go ahead and install it. And this is going to allow for Atom and Python to call different libraries to perform different functions. And each time I use a module or a library, I will tell you up front which one I am using so that you can take time and install it before you start the video. So I think I've answered a lot of what I wanted to get through in this video. There's one other thing I'm going to be saying a lot that you should kind of get familiar with, and that's this term Pythonic. Now, I don't think I used it in this video at all, but I should explain it because I'm going to use it with the assumption that you know what it means. Pythonic is essentially the orthodox, if I can spell orthodox, way to perform or write code in Python. So there are ways in which you should write code in Python. The way in which a community writes code. For example, if you are using the library NumPy, you are going to import NumPy as NP. Everyone does this. And the reason why is because when you call that library, it's a lot easier to call the functions by simply typing NP rather than NumPy every single time. There are certain idiosyncrasies within the Python community like this that you're just going to have to get used to. I'm going to do them. I sometimes break Pythonic orthodox manners, but for the most part, I stick to the Pythonic way to actually write code. And the reason why you do this is because if the community as a whole writes the code in a very systematic and similar manner, it makes it easier to read if you are not the one writing the code, and it also makes it easier to actually diagnose problems. If you actually have a question that's specific to your code, you can post it online, and people will be able to read it and see what's going on. And you'll oftentimes hear the comment if you haven't done something in a Pythonic way that it's not very Pythonic, and they'll give you the Pythonic way in which you should have written your code. Because in Python, like all programming languages, there are multiple ways to perform the same task. But try to always be Pythonic in the way that you do it. And if you don't know the Pythonic way to do something, when you are Googling your question, simply add in the word Pythonic, and you'll return results that typically match the Pythonic or orthodox way of performing a task in Python. So why should you even bother with Python in the digital humanities? Why am I doing this at all? I'm doing this because I believe that in order to actually do the humanities or do history in a large scale, we need to have not only a digital component to our research, but a programming background to that research. Why do I say this? I say this because so long as we think about history or the humanities and we view these subjects through an analog lens, we are really only ever going to pose analog questions. Now, these analog questions might have analog solutions, they might have digital solutions, but they will never be exclusively digital solutions. What does this mean? It means that the questions we pose are necessarily limited in scope. Once we start viewing history and the humanities through a digital lens, we can start thinking about digital questions, questions that can be only answered in a digital medium. So quantitative data analysis is impossible on a large scale if you do not have a digital component to your project. Python, as we're going to see in this video series and the ones that come afterwards, is the solution to that problem. In my own personal research, I'm actually creating a neural network or a series of neural networks to analyze early medieval texts in a way no one has previously done because it's inconceivable. I'm talking about billions of data points that can be analyzed by a computer that wouldn't even take it would take longer than a lifetime to do for a human. But for me, it'll take probably a couple years to code, and once coded, can run tasks in a few days, a few months at most, that would take years, if not a lifetime, to actually do. This is the advantage of thinking about large-scale digital questions. We can pose broader questions and look at change over time in a way that really hasn't been possible just yet with an analog environment. So, one of the cool things that's going to happen to you as you start to work with Python for your research is that you're going to start looking at the world and looking at problems in a different way. So you will find that certain tasks, especially repetitive tasks, will become far more boring because you know that there is a faster way to do it if you simply wrote the code. And as you get more acquainted with Python and more comfortable with Python, you will find that you're just going to start doing these digital solutions to these problems. So one of the problems I had in making this video was I wanted to take all of these lectures and I wanted to actually make individual folders structured in a very specific format with a hanging zero, a number if it's single digit number, and then an underscore, and then this title. But there's a couple different problems with that. I can't just copy and paste because if I did that, then this colon would return an error. But I wanted to have a series of folders for each individual lecture in which I could store the Python code that I'm going to be talking about in that video, and have a couple text files of the things that I'm going to be covering and some of the key terms like you see over here. So there's two options to that problem. I can either go through and manually type in a whole bunch of, 31 files or folders, or I can let a machine do all the work for me. And if you see right here, I have created a very simple Python code that right now won't make any sense to you. I'm not going to go through and explain it, but essentially all it's doing is it's going to each line of, I'll put it here so you can see both at the same time. It's going to each line of this file and creating a folder that matches that name, that follows a very specific pattern and gets rid of all the problematic things like the colon and the commas and the line breaks that you can't see that exist out here, and creates these folders through a loop. It's that simple, and you're going to see how fast this actually goes. And this is, by the way, how I'm wooing the audience with something impressive. Although I think wooing the audience kind of loses its effect if you tell the audience that you're trying to woo them. But you'll see it right here. And boom! All that was done. That was real time. That was how long it took me to create 31 folders. Simply running that code. So that's nice, but what's really cool about this is that this code can be reused. It took me probably about 5 minutes to actually write it all out. That time, I could have probably gotten through about half of the folders, but the next time I need to do something along these lines, I don't have to write the code again. All I have to do is just change the file directory in which this stuff is stored, and I can do that again. You will find that the world will look different to you once you start programming in Python. Even if you're only programming in Python for research purposes, you will find Pythonic solutions to everyday tedious tasks that you don't have to do anymore. So if you stick with me for the next 31 videos, I'm going to take you, a non-programmer, a digital humanist, or a digital historian, introduce you to Python, and get you the key concepts quickly and efficiently so that you too can start incorporating Python into your research. So thank you for listening.